Welcome back. Now in this tab and in the tabs that follow, we're going to kick it up a notch because in most cases there will be a comparison, one person against another, and then we're also going to throw in some questions at the bottom, some multiple choice questions, just to have you reflect on your knowledge. So Delaney sells in the East Division where sales are distributed and means normally distributed. And the first number that you see here is the mean, and the second is the standard deviation, so 30,000, 5,000. Her sales beat the average for her division by 7,000. Nick works in the West Division where sales are distributed 10,000. His sales are 40,000. Find and compare the percentiles for Delaney and Nick. So let's frame the problem, and it's going to be probability below X because we want to see both of their percentiles relative to their respective divisions. In other words, who's performing the best relative to their own division, not relative to each other, relative to their own division. And so we're trying to get probability, so that's going to be our strategy. And the case for Delaney is going to be one tail left, as it is for Nick, because it's the percentile. And then let's get some numbers. So the mean for Delaney is 30,000, and for Nick it's 35,000. Spell or type. And the standard deviation for Delaney is 5,000, and for Nick it's 10,000. And X, Delaney's value, is she beats her division by 7,000. If her division is 30, she's at 37. And Nick, we're given straight out that he's at 40. All right, so let's look at the data so you can kind of see why this is such an interesting problem. So here's Delaney's division, which is the green one. There's Delaney. So she's sort of well above the middle here. She's more than one standard deviation. She's somewhere between 1 and 2 standard deviations above the mean. Nick, on the other hand, his division has a mean of 35,000, and he's not even 1 standard deviation above the mean. So just based on this alone, you would say that Delaney is performing better relative to her division than Nick, even though her sales are lower. Maybe in her division it's harder to make sales. So her sales are at 37, whereas his are at 40. But relative to her division, she's performing better than Nick. And we're going to sort of work all this out numerically. So let's get the z-scores. Is going to be X minus mean divided by standard deviation. And the beauty is we can copy that. And then let's get the probability. So norm.s.dist, the z-score, true. And we can copy that for both of them. So you can see Delaney is in the 91.9 percentile, whereas Nick's only in the 69.1 percentile. So who performed better relative to their division's average? It would be Delaney, because she's in a higher percentile. You can see that over here, right? Here's Delaney, here's Nick. So it's a little bit harder to see when it's all raw scores, though you can kind of see it from here, but it's much clearer here when you're doing a comparison, because now both sets of raw scores have been standardized, right, based upon their z-scores. So there's Delaney, there's Nick, and Delaney represents, she's better than all the green dots to the left. Nick is better than all the black dots to the left, but the green dots, are infused here where they overlap with the black dots. So she's better. Okay, how many standard deviations or z-scores is the East Division rep from the mean? So who's the East Division rep? It's Delaney. Okay, so she is 1.4. How many standard deviations the West Division rep from the mean? He's 0.5. And could you have picked the best performer from the first graph? The answer to that is yes, based on the standard deviations. In fact, we did do that. Okay, and that's it for this one. We'll see you in the next video.